Hello everyone, today we will be solving question number 5 from GATE 2019. The question is the delta O value of NiH2O whole 6 2 plus is 8500 centimeter inverse. The del O values for NiCl6 4 minus and NiNH3 whole 6 whole 2 plus compared to NiH2O whole 6 2 plus are option number A higher and lower respectively, option number B lower and higher respectively, option number C higher in both complex ions, and option number D lower in both complex ions. So what is delta O? We know that there are 5 d orbitals. These 5 degenerate d orbitals split into two energy sets, that is T2G and EG, when they are present in an octahedral crystal field. So dxz, dyz, dxy, dx square minus y square, and dz square. These 5 degenerate d orbitals split into two energy sets, and now this T2G is having dxy, dxz and dyz, whereas EG is having dx square minus y square and dz square. T2G is having pi character and EG having sigma character. The difference between this T2G and EG orbital is the crystal field splitting. This is the energy difference. Okay, so this crystal field splitting depends on mainly on three factors. The first one is metal charge, second one is principal quantum number, and ligand field strength. So first, let's find out the metal charge for the three given complexes. The three given complexes are NiH2O whole 6 2 plus, NiCl4 Cl6 4 minus, and NiNH3 whole 6 2 plus. So if we consider X as the oxidation state of nickel, then X plus water is a neutral ligand and it carries a charge of 0. So 6 into 0 is equal to plus 2, and hence X is equal to plus 2. So here oxidation state of Ni is plus 2. Now for this complex, X plus Cl carries a charge of minus 1, and the charge of the overall complex is minus 4. So x minus 6 is equal to minus 4, or x is equal to plus 2. So in this case also nickel is in plus 2 oxidation state. Now for this ammonia complex, X plus ammonia is also a neutral ligand and carries a charge of 0. The complex is having an overall charge of plus 2, so X is equal to plus 2. So in this case as well, the oxidation state of nickel is plus 2. Therefore, on the basis of metal charge, we can't compare the delta O values for these complexes. Now the next factor is principal quantum number. So in all the three cases, the metal present is nickel. So we can't compare on the basis of this factor also. The other factor on which delta O depends is the ligand field strength. And here we can see that in the three complexes, the ligands given are different. One is having water as the ligand, one is having chlorine, and the other one is having NH3. So the Cl is a halide ligand, which is pi donor, and this H2O and NH3, they are having sigma type interaction with, they are having only sigma type interaction with metal. Now if we look on to the spectrochemical series, in spectrochemical series, the halide ligands are the weakest ligands, the most weak field ligands. Then comes the oxygen donor ligands like H2O, then NH3, PPS3, and then carbon like ligands in which carbon is donating like CO, CN. Okay, so on the basis of the spectrochemical series, we can know that these halides are the most weak field ligands, whereas if we go like this in the spectrochemical series, uh, these COCN, these are becoming strong field ligands. So now, if we are having a ligand which only interacts with the sigma type orbital, then we saw that in an octahedral crystal field, it is splitting the degenerate d orbitals into T2g and Eg, and the difference between these two is delta O. Whereas if we have a, a halide ligand, because of their filled electrons in pi orbital, they are low lying in energy, and this pi orbital of ligand and the T2g orbital of metal, because of its pi character, they interact with each other and it results in bonding T2g and antibonding T2g set of orbital. Now this is the new HOMO, and since EJ is not having pi character, so it will remain the same in energy. This is the LUMO. Since this T2g star is more closer to the metal T2g orbitals, they will be highly metal based, and this will be the new HOMO. And as a result of this, the delta O will decrease when we are having halide as the ligands. Whereas in the case of pi acceptor ligands, because of the presence of empty pi star orbital, like it is there in carbonyl ligands, in cyanide ligands. So because of the presence of empty pi star orbital, this pi star will lie higher in energy and we will have this T2g and Eg orbital. Now again this T2g and pi star orbital, they will interact with each other and result in a bonding and antibonding set of T2g and T2g star orbitals. Now here, as this bonding T2g is closer to the metal T2g, it will be highly metal based and it will have the metal character. So this is the new HOMO and this is the LUMO. So in this case, from this as delta O when there is no pi type interaction to when there is a pi acceptor ligand, the delta O value is increasing for pi acceptor ligands. So from this, we know that for halides, it will be the minimum. So the metal complex in which Cl minus is the ligand, the delta O value will be least for that. And in spectrochemical series, we can see that H2O is a weaker field ligand than NH3. So this will be the order of the delta O values. Coming back to the question, that means NiH2O whole 6 2 plus will have lower delta O value than NiNH3 whole 6 2 plus, and it will be having a higher delta O value than NiCl6 4 minus. That is because it is a weak field ligand compared to these two. So among the given options, this NiCl6 4 minus will have lower delta O in comparison to this. So B and D, here it is lower, and this NiNH3 whole 6 will have higher. So lower and higher respectively. So among the given options, option number B, that is lower and higher respectively, is the correct option for question number 5. To know more about this topic, please refer to the lecture series on coordination chemistry by Professor Devashish Rai from Department of Chemistry, IIT Kharagpur. This is the link for the lectures. Thank you.